Okay, so in this particular example, you have another average speed problem here where you have a couple of different segments going there and coming back to the same starting point. Okay, so if you want, take a second, pause the video and read the problem before I start. Okay, so let's get going. I highly recommend for these types of problems, if you can, if you can't visualize it, definitely draw a diagram out. So I kind of made one for you. As stated in the problem, there are two different segments. The first segment, the bike rider or the cyclist here is traveling at a rate of 20 miles per hour as stated, and that distance is 10 miles. So I made a diagram from A to B and I labeled those given quantities for you. And then as you read the problem, it says for the second leg, the bicyclist is traveling at a rate of 16 miles per hour and that distance is 20 miles, or it says remaining, which is the second leg the problem here. So from B to C, I labeled the rate as 16 miles per hour, and then the distance here is 20 miles as given. And it asks for us to find the average speed just for the return trip. So from C all the way back to A. Okay. All right, so let's get going here. So hopefully by now you are familiar with the average speed function. Speed is just simply distance over time, but I encourage you to go ahead and know the two also to the right of this, and that is if we were to isolate for t, t would simply be d divided by s. And then if a question asks you to solve for distance, in this middle function here, if we solve for d by itself, you would multiply both sides by s. So distance would simply be the speed times time. So really, why there are three equations here, it comes from the same fundamental function, which is speed is equal to distance over time. Okay, so let's go ahead and use these functions here. I went ahead and broke up my work into three columns. One is from A to B, which is the first 10 miles. The second column here is from B to C, which is the next 20 miles. And then from C all the way back to A, because the question asks us to find the average speed for the returning trip, which is from C to A. So I encourage you start with fundamental functions that pertain to the different parts or different segments. So what I notice here in the first segment from A to B is that my speed is given, the distance is given, the quantity that is not given is t. So I will go ahead and set it up where I'll use this middle function, but then I'll use subscript. From A to B, I'll just call that segment 1. So t is equal to distance over average speed. Now, why do I do this? Because if I'm looking at the diagram or if I'm reading the problem, these two quantities are given to me. It tells me that the distance is 10 and then the average speed is 20 miles per hour. So really the only thing I don't know is the time. So I might as well just start with the time function and set it with that. Okay. Likewise from B to C. You can also start with the time function simply because you're given the distance, you're given the average speed of that segment. So the only unknown variable is your time. So I have it here as T2. And then again, I've learned to use subscript just to differentiate problems when they are different. And then from C to A, I encourage you to read the problem again if you haven't done it carefully. It asks for the average speed for the return trip. So here, I would start with the average speed function, which is equal to distance over time. Again, you got to focus on what's being asked of you. You got to focus on what's being given to you. So here, for the third column, I simply stated that the average speed is distance over time. That's because the question asked me for average speed. So I might as well just use that function, okay? All right, from here, you need D3 and T3. But to figure out D3, really it's just the total of the two segments. Because from C to A, it's just the distance from A to B and the distance from B to C. So what I've done here in my work is that I just added the two distances up. So if I take 10 miles plus 20 miles, that would equal 30 miles. So therefore the distance from point C all the way back to A is simply 30 miles, okay? Now, it asks for the average speed for the return trip, but in the statements, it said that the whole entire trip took 4 hours. So in order to find the remaining time or the leftover time, you have to take the total time. In this case, it would be 4 hours because it states that the whole entire trip from A to C and C back to A took a total of 4 hours. So T total here would represent 4 hours. And then you know what's missing here is T2 and T1. I don't know what these quantities are, but based on my work and setup, I can find what T1 is and T2 is, simply just plugging and chugging. So let's go ahead and find T2 and T1. So I'll go from left to right. So to find T1, simply plug in the values that are given to you. The distance is 10 miles. The rate is 20 miles per hour. Here I've broken mph into miles over hour because that's what it is. And the unit miles will cancel out. So 10 over 20 simply just reduces down to 0.5 hour or half an hour. So we already solved for T1 here. Okay. So pretty much the only thing missing from here is T2 in the last column. But then the information for T2 can be calculated simply by using the information from B to C. So T2 is simply D2 divided by average speed for the second leg, which is given to us. So the distance is 20 miles, and then the average rate is given to us as 60 miles per hour in the statement, in the wording. And then if you do the math and you do this properly, your calculator should give you 1.25 hours. So right away, if I just use common sense, from A to B took a half hour, from B to C took 1.25 hours. So total, it would be 1.75 hours. So now I can just plug and chug here, okay? All right, so here in my work, I replace D1 with 10 miles because that's what it is in the diagram. D2 is 20 miles. And then the 4 hours, again, comes from the statement. It says the total round trip time was 4 hours. But to find the leftover time, the time to go from C to B, I would just subtract how much time has been used up. So the first leg took a half hour. The second leg took 1.25 hours. So to find the remaining time in math, we would just subtract all these values. So if you do that properly, the numerator reduces down to 30 because 10 plus 20 is 30. And then 4 minus 1.25 minus 0.5 is 2.25 hours. And then calculator time, 30 divided by 2.25 is simply 13.33 miles per hour. Okay, I hope that helps in terms of breaking it down different segments. And that is my dog barking at someone at the front door. All right, stay nerdy.